Hi, this is Karen O'Brien, and we are going to work through QGIS Lesson 3 to add the storm drain system from a set of shapefiles into our map. So what you'll need is, well, this has two data sets, kind of depending on where you are in the model, but it should work about the same way either way. So if you don't have the latest version of the plugin, you can just follow through without the pumps and maybe things will change a little bit, but you can basically just ignore anything relating to pumps. Or you can use the shapefile that has the pump in it. So you'll see that you'll have a separate shapefile that's called pumps. And then you can just work through the full lesson without any issues. So your project data is in QGIS Tutorials Lesson 3. And the steps will be to open the project and load it, import our storm drain shapefiles, select the storm drain fields from the shapefiles, assign the link node connections, import the rating table, set up the pump data, and then schematize the storm drain, export the data, and run the simulation. So it shouldn't take too long to get through this. I've already gone through the first step, which is to load the project and clean the map up a bit. Now, if you do want to run through this with the storm drain, pumps, and the new plugin, go ahead and get that here. Just be aware that this is a experimental plugin and it's not quite finished, but the pumps are finished. Alrighty, so I will start with step 2, which is to select this layer right here and then drag these shapefiles onto the map. I've already cleaned up my map by unchecking this data and unchecking anything that I don't want to see. So let's go ahead and go to Lesson 3. And in the Shapefiles folder, we should have with pumps. And I will be dragging these onto the map. And I think I told you, I can't remember, but I should click this before you do that. Drag these onto the map, and this is our storm drain system. So these are the conduits, and then I have one pump right here. It is also it's called a link. So conduits and pumps are links. And then we have the inlets and junctions, which are catch basins, grates, things like that. And of course, T's and Y's and any kind of break in slope you might have as a junction. And then here are the outfalls, and most of my outfalls, all of my outfalls connect to the Greenway channel because that's basically the low point of this project from both sides. All right. And it also, in the lesson, it also tells you to review each of these shapefiles so that you can see how they're set up. So if you check out the attribute table of each of those layers, you can see these fields. Now, not all of the fields are in each shapefile, but for the conduits, the fields that are there are the ones that are not marked, not required. So you don't have to have an initial flow. You don't have to have an entry or exit loss coefficient. So those are not required fields. But some of those features do need those, but for the sake of simplifying this lesson, I left them out. If they have a little asterisk on this, that means this data right here will be filled in by the plugin. So you may not have to have this data, or it could just be dummy data if you have to have it. If you get an error message saying you need to check that layer, you might need to have at least something in that field, but it could be just dummy data. And they are the inlets and junctions. Again, each of the requirements is outlined in here. For the inlet name, if it is an inlet, the name should begin with a capital or lowercase I. That tells Flow2D that inlet should exchange with the surface. The outfall files and the pumps. This is the data that would be required for the pumps. And since they are a link, they also require an upstream and downstream node to link them between 2 points. So that is, oh, and by the way, you can see that by right-clicking and opening the attribute table to review the data. And you won't need these two right here. Okay. let me go ahead and open the storm drain editor. So again, I always collapse everything because I don't want to have too many of these open, and then go to the storm drain editor. And then the first thing that we need to do is to select the components from the shapefile layers. So if I click on that, it starts out on inlets and junctions, and then what I want, these are point files, what I want are inlets and junctions. Then I'll choose the name from the list of attributes, the inlet type from the list of attributes, invert elevation, max depth, length, width, height, weir coefficient, and the feature switch. So the only thing the feature switch does is it changes a type 4 feature from horizontal to vertical. So if the feature is horizontal, meaning it's like a grate that lays on the ground, then the feature switch is 0. If the type 4 is a vertical inlet, meaning that it's a head wall, then the feature switch should be set to 1. Otherwise, for all other inlets, it's not used. It can be null or 0. Outfalls. If you set that, oh, sorry, I didn't, hang on. Let me try that again. I forgot to turn one on. Okay, outfalls. If you set, well, it picks it because it remembers, so you only have to do this once. So name, invert elevation, whether or not it has a flap gate. Allow Q will allow discharge to return back to the grid. In our case, all of our discharges are returning to the channel, so our allow Q switch would be set to 1 or yes, meaning allow flow back. And then the outflow type could be like a free outfall condition, meaning there's nothing to control the discharge leaving the system, or it could be a fixed or whatever, and you can see that when we get into those attributes later on. Conduits. Conduits, you do need an inlet and outlet offset if you have offsets in your conduits. I don't have any offsets, or I'm not using offsets here, just to be simple for the sake of making this a simpler lesson. The conduit shape is the pipe shape, number of barrels. We are only using circular, so I only have this field set to diameter. Pipe length, manning roughness. We don't have an initial flow or a max flow for any of. I'm not applying any loss coefficients because just to simplify the lesson, and I'm only using circular again, just to keep things simple. Pumps are pretty simple. They have a name. These are the connector nodes. They'll be defined with the buttons over here. An initial status, which is either on or off. A start depth. So my initial status is off, and then I have a start depth of 1 foot. Stop depth is, I think, 10 feet or 30 feet or something like that. And then a curve name, and then these fields are not connected to the system yet. So I'll click Assign Selected Fields, and what this is doing is it is committing the data from these layers into these guys right here, and some of these tables down here. Some of these tables can also be filled. So it won't fully commit the data until you hit the Schematize button over here, and that will then fill these guys. Right, so let's go ahead and go back here and see what this guy says to do. So we select the components, and then it tells you how to set up each window. Are we missing one? Junctions, outfalls, conduits. Yeah, nope, pumps. Yeah, here we go. And then it says if you're not using pumps, just skip this and just click unselect all. Okay, then we clicked OK, or clicked assign and clicked OK. And then the next thing to do will be to assign the link node connections. So let's go ahead and minimize this. So the first thing we do is click simulate the storm drain, and then we need to assign the link nodes. So I'm going to start by doing the conduits, and that's going to do 271 conduits. And then I'll do the pumps, and that is also complete. So now what that did is if you go to the conduits dialog box, what that did was it filled in these two fields from the nearest inlet and outlet. Now let me show you how that works, because this is very important when you're setting up your own system. You'll need to know how this works. So when a conduit connection is created, what it does is it looks at each individual polyline, and it does a query of the node that is closest to the very first vertice and the very last vertice or vertex. So it's going to apply, and so it's going to take the direction of the pipe is very important, because if you don't do this right, then it's going to set that up backwards. So what you want to do when you're building your system is make sure that your arrows are always pointing in the flow direction from upstream to downstream. And then if this node, so when you click assign link nodes for conduits, every single conduit will be queried, and it's going to do a search to intersect it to the point of the upstream, and it's going to have a search buffer of like 1 to 3 feet. I don't remember the exact search buffer, but I'm going to say 1 to 3 feet. And it's going to identify the name of that node and assign it to the upstream node. And it's going to do the same thing to the last vertex, going to do a query with a buffer of 3 feet, and it's going to assign that node name into the dialog or into the data table. So if you go to open the conduits and you click on some of these and you return, and if you labeled the points from the inlets, you would see that the names should match up unless the flow direction is bad. Okay, so that's how these work. Also, this table is pretty handy. You can either type in or select a feature, and it will zoom you straight to that feature. And you can edit the properties here. However, I don't like to edit the properties in this dialog box, because then the data is not in here. So I like to put my data in here and keep my data in here. That way, instead of editing individual nodes, I can just run this guy again, and you can run that as many times as you want, and then do your edits in these layers, because this system is very accurate and good. Okay, so I think I probably might have overwritten some of my data. So since I clicked that again, I'll go ahead and run these auto assigns again. So we'll start with the conduits and then move on to the pumps. I don't have any orifices or weirs, so I'll just leave those alone, and then go back to the dial or back to the lesson to see what's next. So simulate the storm drain, auto assign the buttons, or click the auto assign for the conduits, repeat the process for the pumps, and then click the buttons. All right, next is to import the rating tables. So I do have one type 4 in this project area, and the way that this type 4 works is that, let me turn the image on real quick, that as the water gets onto the invert of this feature, it will start to enter the feature, and it basically uses the rating table that allows the water to enter this feature and assigns that as the inlet condition on this node. Now I set the node up here because the elevation of this grid element is high, because most of the elevation is coming from up on top of the head wall, not down on the bottom of that head wall. So I can put this feature right here, and then the invert elevation of this node right here would reset the grid element elevation of this cell. That's okay, we'll do that automatically. Or I just put it out here where it's a little bit closer, and then I don't have this kind of chunk of low elevation right here. So either way you want to do that is probably okay. But we do need to assign a rating table to allow the water to get into this feature. So if I come over here to the rating tables, I can load them from a predefined table. In this case, I only have one, but just like with your culverts, you can select as many of these as you have, and the plugin will identify and connect them to the links, and if they, or sorry, to the nodes. And if they're not a proper assignment or allocation, it will give you an error message and show you that data. So I'm going to click open, and it's going to tell me that one file was selected and one rating table was assigned. So if I had 20 and only 19 were assigned, this error file would tell you which one was not assigned. If I click OK, and be careful, because this is where this error file goes. And I'm going to click OK. And then if I go back here to my shapefile folder, because this is the location of where I selected this from. This is the error file I was telling you about. So if I open that in Notepad, it just tells me what was assigned. And then of course, if one wasn't right, it would tell me that something was wrong and how to fix it. Okay. So that's how you load your rating tables for type 4s. It's very easy. And then for the pumps, I only have one pump. I can either add predefined curves from the files, or I can, which is the exact same system as this, or I can just create the pump curve using the table. So if I click this button, and then I name the pump curve to P1, and I'll show you why I named it to P1 in just a second, then I can put a pump curve in here. So this is 0, 0, 1, and then we'll say 30, and then this can be, let's just say it's just a linear pump, or it's just a steady state pump. And this will use a kind of like a variable depth curve to apply this data. And if I come back here, well, hang on, let me just make sure. I'm going to set that to type 4 pump, and then I'll just put a description in here, 20 CFS steady. I mean, it's not really steady because it has a bit of a curve up here, but I'll show you what they do in just a second. And that is basically done. You don't have to do anything else to finish that. But two things I wanted to show you was that the reason I assigned that, or I named that P1, is because our pump is named P1. And let's see, what else did I want to say about that? If I come back here, I wanted to also show you that, so we are into step 6, set up the pump, and it just shows you how to set everything up. But if you go to the EPA SWIM help document, you can search the document for pumps, and it will give you lots of information about the different types. So the pump type 1 is a incremental flow pattern based on flow and volume. Type 2 is an incremental pattern based on flow and depth, so it's just stepped. Type 3 is an inline based on head and flow, and type 4 is a variable speed pump with flow and depth. So I can probably use this one or this one if I have a flow to depth relationship. And then if you just want to use an ideal pump, this one is very simple. You don't need a curve. All you need is a star in the pump data, and it will just take whatever flow is provided to it based on what's coming into the inlet. So it'll just take everything. And there's more information in that manual. And here's the location of that manual that was installed onto your computer when you installed Flow2D. All right, so the next step is to schematize the storm drain components. So we'll go ahead and schematize that, come back to QGIS, and we will click the schematize button right here. And it's just going to tell you that the storm drain were finished. The inlets, outfalls, and rating tables were updated. Note, now you need to export the data files to write the attributes into swimflow.dat, swimflow.rt.dat, and the swimoutf.dat, but we also need the swim IMP file. So I click OK, and I think the final step would be to export, or the next step will be to export the data. So we come back here. Oh, and I also should show you, sorry, I forgot to show you something, that these layers are now updated. You can see that there are inlets assigned to the centroids of the cells for every cell that can exchange with the surface. You don't get an inlet for a junction. That does not exchange with the surface, so it doesn't come into this layer. And then you also get the outfalls, and all of our outfalls really need to be assigned to a left bank, even though all of them are coming either, to the bottom of the channel or possibly the side of the channel. They always need to be assigned to a left bank. They will fill the cross section, not the bank, okay? That's how they work. They don't They don't make their exchange on the bank, they make their exchange on the cross section. But with Flow2D, the bank nodes are always tied to the cross section number. So that's why we always assign everything to a left bank when we're interfacing with the channel. So you have to do is when you're going through here, just make sure that each of those green dots is on that's assigned to a channel is on a channel. I think that's the only, there's a couple more right here. They all look good to me. And one more, I think I missed one. Oh, no, there's a bunch right here. Okay, and a handful right in here. Okay, so all those are finished. And now we can export the project. So let me get back here, just make sure I do everything right. So export the project. One, set the control variable icon or check them. They're just going to validate that everything is turned on and that your storm drain switch is checked. So we can do that now. So we want 24 hours, 0.1. This can be text or graphic. If you set this to graphic, this needs to be like 0.1 or 0.5 or something. It's just the update interval. These two we set in lesson 1. Main channel. Do we have levees? Not yet. Don't have levees yet because I didn't put in the walls. Rainfall, infiltration, storm drain is good. Hydraulic structures. And these two are should always be 2 unless you're doing some troubleshooting. And this one is 3. And at this point, if you wanted, you could also put on some time series output so that you could review the data in the results along with the storm drain results. So I'll click save, and then next step is to run through the export process. So we click, well, you can save the project right now. That's true. And then you can export the data. So this is a little bit newer. So what happens now is we don't have to export the INP separately anymore. It's going to export it with the whole project. So if we click the export button, we go to the lesson 3 export folder and just export all the normal main files, all the .dat files, and then the INP file export will be automated. You'll have to, run through that. And then this is just the data that you can export with the INP file. I'll talk about it a little bit more later. This is what was written to the INP file. These are the, I guess, fields or areas that were written to the INP file. These are the new storm drain files, and then the export is complete. So let's do that. So we come over here and we click this button. Well, actually, let me just, I know I've just done this, so let me just check it real quick. Okay. And then we click on that, and then we select the folder. So just go back a level, select lesson 3 export, and click. Now I'm going to pull this over. I'm going to click OK, and you'll see that these guys are written to the file. And then once these guys are written to the file, the IMP export is initiated. So we always have to use swmm.inp and make sure you set that to the correct location, and then make sure that, well, you can set these up however you like to set them up. The reporting step right now matches the Flow2D reporting step, but it doesn't have to. You can set that to something different. And then I'll just click OK to write that. And this tells me that these are the sections that are used, and these are all of the data files that were written. So you should see that they should match. And then if you come over here, I'll just go over these input files real quickly. So swim.inp is pretty standard. There's a lot of things you don't need for Flow2D. So this is set up for Flow2D. So if you have other things in here, Flow2D might ignore them. And you can go over better storm drain lessons to get an idea of how to set these variables. So all your junctions, note the ones that are connecting to the surface have an I. And then we have the conduits. And again, these, remember, were auto-filled. These upstream and downstream node connections were auto-filled. And then we have our pump, and then our links, and losses. Remember, we didn't use any losses, just to be simple. Curve names, this is our pump 4. That's our pump type, and the name was P1. And these are just the values that are applied to that type 4 pump curve. And report settings, this is just what you want to do when you're reporting. And these are your coordinates for all of the data. And we don't have any inflow, we don't have any time series, we don't have any patterns or any control, so those are all zeros. We also get the INI file, which you can also open with Notepad. And it just says a couple of small things here. This can be pretty extensive, but all we need for Flow2D is just these variables right here, the version and the results, and this helps to do your animation inside of, or your time series output inside of the Swim GUI. You can also open this IMP directly in the Swim GUI. I'm going to open the Swim GUI real quick just to show you how this works. And so if you just drag your IMP over here and drop it, you can see that your project loads right up, and then you can use the Swim GUI to review the profiles and to review something that, an inlet or something that might be having problems. Anything that you can review inside the Swim GUI, you can review for Flow2D. The only difference is in Flow2D, you don't need subcatchments. And in a regular Swim file, you do need subcatchments. All right, let's get back here for a sec. Here we go. Okay, so we also have these 3 files, and this is the data related to Flow2D. I'm going to open that in Notepad because there's 3 of them. And I will turn off the end of the line symbols because we don't need to see those. So these are the inlets that connect to the surface. This is the grid element they connect through. This is the inlet name, and these are the geometry and inlet type. This is the inlet type, and these are the geometry and weir coefficient, etc. Other switches you might need for that. And you might see if I hit Control F, I name mine just to help me track them. I typically name mine the type of inlet that they are. So if I have a type 4 in here, that's a head wall. You can see that it indeed has the feature switch right here, and it's assigned as a type 4 right here. So this is basically just the geometry that connects, that feeds the inlet, and that inlet is what feeds the storm drain system to get the water exchange to occur between the surface and the storm drain. This is just the rating table for my type 4. It's the grid element number, the name of the type 4, and then the depth and discharge relationship for the head wall, or for the headwater condition. There's no tailwater control in this rating table. And this is the outfall file. So these are each outfall, the left bank channel grid element that they attach to, and 1 means that they do return water back to Flow2D. If they were 0, it would be like a sink, like they went across your boundary, or they went up to your boundary. You would set those to 0, and then that would act just like a sink, and the water would just leave the system at whatever control pattern you set it to in the INP. Could be a time series, could be tied, could be free, or it could be fixed, a fixed stage. That's it for the 3 Flow2D or Swim related files. And the final step, I believe, is to run it. So let's go ahead and go back here and just make sure we do everything right. So we'll click the run icon and make sure that these 2 are set correctly. And let me minimize this. That's pretty simple. We just click this. This has to go to C drive program files x86 Flow2D Pro. But if you are following along from lesson 1, that was set back in lesson 1, so you shouldn't ever need to reset that unless you, delete your plugin or something. This one is set to lesson 3 export folder because that's where our run is. And if I click OK, it should initiate the run. And I'll show you this over here. The data is loading and it is initiating the run, and now it's running. So we don't want to mess with this anymore. We want to just shut this down so we don't actually mess with it and let this continue to run. We can go on and work on lesson 4 now. And that's the end of this video. So I'll go ahead and stop this video and you can pick the sequence back up with lesson 4.